All right, so let's try some examples now. Okay, so we have the concept of eliminating. So let's remember, what does that mean? We want to get to 0. Okay, we want to cancel out a variable. What did we notice to cancel out a variable? Well, look at example 1. Okay, is there any numbers that are opposites of each other? What do I mean by that? They're the same number. One's positive, one's negative. Do you see any there? I hope you do. Okay, this one's pretty obvious. You have a negative 7x and you have a positive 7x. If we add, that's what this whole concept of elimination is we're adding our equations together. If we add this, will the x value be eliminated? I think so, so let's give it a try. Okay. All right. Once we find something that is the same number, opposites of each other, one's positive, one's negative, okay, we're already moving to the next step. We're going to add our equations together. So what is negative 7x plus 7x? 0. It's eliminated. Let's move to the next thing. Are these the same variables? So can we combine like terms? Yes. Negative 6 plus 8. I believe that's 2. And it's a y. Almost done. Look at our constants. They're constants, so they're like terms. What's negative 14 plus 0? Negative 14. So far, so good. Now, how can we get y by itself? Divide by 2 from both sides. And what do we know? Y equals negative 7. Okay? You guys are probably like, oh yes, we're done. No. Okay, once again, we're working with systems of equations. What do we know is systems of equations? How do we get a solution? Well, where these two lines intersect. To be an intersection point, what do you need? Well, you need an x value and you need a y. Well, we have our y. All we got to do now is to find our x. Okay, so once again, let's go ahead and put our coordinates up here. We'll put negative 7. Make sure you put it where the y is supposed to be. That's a common mistake. Okay, we need to still solve for x. So what are your thoughts? Oh, pretty easy. Let's take this number and substitute. Okay, that should be a very common word right now because you have learned how to substitute to solve a system of equations. We're basically doing the same concept. We're going to take this negative 7 and plug it into y. Guess what? You can choose whichever one you want to do. Now, I'm going to tell you right now, I'm going to use this one right here, y. I got some easy numbers. They're positives, it equals 0. Not too bad, okay? So let's take negative 7 and plug it into y. So we have 7x plus 8 times negative 7 equals 0. Okay? Can we solve for x now? Yep. 8 times negative 7 should give you a negative 56. Okay. Add 56 to both sides. You should know how to do this already. You're left with 7x plus 50, or 7x equals 56. Divide by 7, and we get x to equal, what do you know? 8. Okay, x equals 8. Put it up in your answer, you're done. You found the intersection point, you solved the system of equations. Pretty easy, right? Not too bad. Okay, let's try another one like this. All right, take a look at example 2. Okay, what do we need to look for first? Okay, we need to look for same numbers, but opposite signs. One's positive, one's negative. Okay, hold up. I see some of the same numbers going on here, but are they opposites? No, they're both positive, so we have an issue. What do you think we can do to maybe make one of these 4s a negative? Well, you could either multiply by -1 or just flip all of the signs in the equation. Okay, I'm going to multiply by -1 just because I want to keep it consistent. Okay, whatever you do to one thing, you must do it all the way across the board. Okay, that's a common mistake that I see. All right, so what do we get? Well, we get -4x minus 2y equals negative 8. Negative times a positive is a negative, negative times a positive is a negative, negative times a positive is a negative. Okay, just flipping all the signs. Do we do anything with the top one? Nope, just bring it over. I like to keep it organized, keep everything lined up, as you can see. Now, same numbers, positive, negative, we're good to go. Let's start eliminating. So let's add. What is 4x plus negative 4x? 0. It eliminates. Goodbye, x's. How about negative 3 plus negative 2? Two negatives together, we're just going to add them up to get negative 5. Okay, so far so good. Okay, last one. 18 plus a negative 8. Okay, that'll give you 10. Last but not least, can we get y by itself? Sure. Divide by negative 5, and you're left with negative 2. Okay, one intersection point, one coordinate ready to go. We got negative 2 for y. Remember, put it in the y spot. Okay, what are we missing? X. Okay, how do you think we're going to solve for x? Well, we're going to take negative 2, which is our y value, and maybe what? Plug it into the original problems. You got it, just like substitution. Let's see. I'm going to use the second one again. Once again, it's all positives. I like positives, okay? So I'm going to take negative 2 and plug it into y. Okay. 4x plus 2 times negative 2 equals 8. We want to solve for x, so we must be doing it right because we have x by itself. 2 times negative 2 is negative 4. Add 4 to both sides. Okay, 8 plus 4 is 12. Divide by 4, and we get x to equal 3. Okay, plug 3 here. Did we find our solution? We sure did. We sure did. Okay, awesome job. All right, moving on. Got 2 more examples, a little bit harder. Okay, this is where we're going to need to multiply by some type of number so that we can match up our numbers. So let's take a look. Hold on, give me 1 second. All right, let's take a look. We have 6x plus 4 equals 24, negative 2x minus y equals negative 14. Okay. Does any of our variables match up number-wise? No. But could we maybe manipulate one of the equations so that we have multiples that are the same? Make it easier on yourself. Start with this number over here. I'm going to change. Can we get from negative 2 to maybe negative 6? What can we multiply by 2 by? Oh, you got it. 3. Because wouldn't 2 times 3 make it 6? One's positive, one's negative. We can eliminate those x's, right? All right, let's do that. I'm going to multiply 3 by everything. Okay, what is 3 times negative 2? It's negative 6. 3 times negative 2, negative 6. 3 times negative 14. We're going to get negative 42. Okay. Did we change anything up here? No, just slide it across. Once again, I like to keep everything nice and organized. Oops. Sorry, guys. Okay. Okay. Same numbers, opposite signs. Let's add them up now. Let's see if we can eliminate. 6 minus 6, 0. 4 plus a negative 6 is negative 2y. 24 plus negative 42 is negative 18. And last but not least, can we get y by itself? Absolutely. Divide by negative 2. Negative divided by a negative is a positive. Pretty nice. Not that bad. Do we have an x value yet? Make sure you put it in the right spot. Okay. What do we do? Now, do you think we want to plug this into what we changed already? No, I don't advise that. It's not going to work out for us. Okay, I like to use the original problems, just like we did in the substitution method. Okay, use the original problems. Once again, work with positives. Makes our lives a lot easier. So I'm going to use the first equation, plugging in 9 for y. So I have 6x plus 4 times 9 equals 24. Okay? 6x plus 4 times 9, I hope we know that it's 36, equals 24. Okay? Subtract 36. Okay? We get negative 12. What do we do now? Divide by 6. We get negative 2. Good. Are we done? Did we find our intersection point for the solution of the system of equations? We sure did. Negative 2 and 9. All right. Okay, this is the big one. Prepare yourselves. Okay? That was relatively easy. We only had to manipulate one equation. Watch out. We got to manipulate both on this one. I even helped you out, giving you a hint. Because, are they the same numbers? I got 6, 5, and 2, and 3. But could we maybe get to a multiple that both of these are in common? So a common multiple for both of them. Well, I can maybe change this 5 into 30, and I can change 6 into 30. Okay, then I could eliminate those. Or look at your y's. Let's see if we can do it over here. Let's change it up. Can I maybe change the y's to get to what number is in common with both of those? That's right, a 6. Yeah, I can change that to get into a 6. How about we take that route? Okay, how do I change 2 to get to a 6? What would I have to multiply by? You got it, 3. Let's distribute. 3 times negative 6 is going to be a negative 18. 3 times negative 2 is going to be a negative 6. And what is 3 times negative 30? You got it, negative 90. Okay. How do I get this one to change to a 6? What would I have to multiply by? 2. Good. 2 times 5 is 10. 2 times 3 is 6. And 2 times 17 is 34. Good deal. Now, do you see something? Hey, are we going to about to eliminate? You got it. Our y's are now going to eliminate. Is that okay? Sure. Okay, let's add straight down. Negative 18 plus 10 is going to give us negative 8x. What's negative 6 plus 6? Well, that gives me 0. Gets eliminated. How about negative 90 plus 34 is a negative 56. Okay, can I get x by itself? Yep. Divide by negative 8. Okay, negative 56 divided by negative 8 is a positive 7. Okay, so one of my coordinates, I'll put that over here, is 7. Make sure you I almost put it in the wrong spot. Okay, put it where the x is supposed to be. Okay, what do I do with that? Plug it into an original problem. Okay, so let's plug 7 into this bottom one. Once again, it's all positives. I like working with positives. So 5 times 7 plus 3y equals 17. 5 times 7 is 35 plus 3y is 17. Subtract 35. Okay, so we have 17 minus 35, which is negative 18. Divide by 3. You got it. Y equals a negative 6. Put that into your final answer. And did we find a solution? We sure did. Okay. All right, on the next video, you're going to see some try problems. I really want you to try these. Okay, this is a hard concept to get. We're going to try some problems, and then we're going to summarize the lesson.